So last time we discussed about masonry. So this time we will discuss about metal reinforcement. Steel is the most widely used reinforcing materials for almost all types of concrete construction. It is an excellent partner of concrete in resisting both tension and compression stresses. Comparatively, steel is 10 times stronger than concrete in resisting compression load and 100 times stronger in tensile stresses. The design of concrete assumes that concrete and steel reinforcement acts together in resisting load and likewise to be in the state of simultaneous deformation. So, pag nag-design daw tayo ng concrete, ang sabay na re-resist yung, pag nag-design daw tayo ng reinforced concrete, reinforced kasi mayroon tayong reinforcement steel na tinatawag. So, pag nag-design tayo, simultaneous yung pag-resist sa load. So, sabay yung pag-resist nila sa load. So, kung pag sabay yung resist nila sa load, sabay rin yung deformation nila. So, ito yung mga typical nga natin na deformed steel bars. Ang tawag dito sa mga, ito dito. Yan, sa mga ganyan natin, ay tinatawag natin surface deformation. Merong mga ganyan para mas kumapit yung concrete natin sa steel bars natin para pag hindi sila agad-agad na maghihiwalay yung para lakas yung kapit ng concrete natin sa steel bars. So, ito yung mga standard tables natin. So, table 3-1, standard weight of plain or deformed round steel bars in kilogram. So, ito, in meters tong length, ito yung kadalasan na available sa market. 6 meters, 7.59 hanggang 13.5. So, diameter ng mga bars natin, 8, 10, 12, 16, 20, 25 hanggang 36. So, pag bibili ka ng bakal na 16 mm na length ay 6 meters, ang weight niya in is 9.47 kilograms. So, yan yung length ng natin. 16 mm diameter na 6 meters na steel bar. So, yan natin yan. So, pag mas mahaba yung steel bar natin, so, big sabihin mas mabigat yan. Yeah. So, pag 36 naman, na 6 meters, 47.95 kilogram ang bigat. So, ito yung mga deformation requirements, mechanical properties of steel bar. So, meron tayong non-welded deformed steel bar, at meron tayong weldable. So, non-weldable, sabihin, hindi mo ma-weld dyan. Tapos, meron tayong weldable, pwede weld in. Tapos, meron tayong yield strength. So, yield strength yung kadalasan na nagamit natin. Okay. So, ito yung mga tables na natin kailangan. So, may mga grade rin. Grade 230, tapos grade 415. Maintindihan nyo yung mga grade na yan pagdating nyo sa design of concrete structures. So, punta tayo sa estimate natin. So, in order to provide a higher degree of sufficient bond between the concrete and the reinforcement, steel bars were provided with a surface deformation in various forms and design. So, ito nga, yung sinabi ko kanina, yung tinatawag natin ito, yung mga ganyan, tinatawag natin surface deformation. So, iba't iba rin yung design niya. So, depende rin kung paano sa manufacturer. So, steel reinforcing bars are provided with distinctive markings identifying the name of the manufacturer with its initial brand and the bar size number including the type of steel bars presented as follows. So, N for billet, A for axle, tapos rail sign is equal to for rail steel. So, ito yan. So, ito yung main rib natin, ito. Ito yung sa edge ng natin, ito. Ito yung cross-sectional, tapos ito yung main rib dito. Yan. Yan yung main rib. Ito yung dalawa. So, M, kung ano yung initial ng manufacturer. Yan yung ano, kung S man yung initial, S na yung lalagay nila. So, kung ito, bar size, nakalagay dyan, it's either as, yung kanina, 6, 10, 16, no, ngayon 6 nakalagay dito, ibig sabihin 6 mm lang yung bar size ng ano natin, bakal. So, kung 10 nakalagay dyan, so yung 10 mm. Tapos, may nakalagay dito, steel type. Ngayon, kung ano yung type ng steel natin kasi ito N for billet. So, ito for billet lang to. So, meron tayong mga grade 40, grade 50. Yun yung mga strength natin category ng bakal natin. Yan. So, ito naman, para dito sa specific na design na ito, meron tayong one line daw is grade 90. Pag 2 lines is grade 75. So, yan. So, tingnan nyo, iba-iba yung design ng surface deformation nila. Ito, pa-horizontal lang, katulad nito. Tapos ito naman, cross. Yan, ganyan. So, depende rin yan sa manufacturer kung paano ang design ng surface deformation nila. So, punta tayo sa bar splice, hook, and bend. In estimating the quantity of steel reinforcing bars, one has to consider the additional length for the hook, the bend, and the splice. So, natin yung kung ano yung hook, ano yung bend, tsaka ano yung splice. So, whose length varies depending upon the limitations as prescribed by the National Building Code. So, meron tayong sinusundan na limitations based sa National Building Code of the Philippines. So, how to determine splicing length of steel bars? So, meron tayong tinatawag na types of reinforcement. There are two, tension bars and compression bars. So, minimum splice length for tension bars is equal to 25 times the bar size. Bar size, sabihin ko ano yung diameter ng bar na ginagamit natin, plus 150. That is for tension bars. Pag compression bars naman, it is 20 times bar size plus 150. Nakalagay dito is 160 pero typo lang yan, 150 dapat yan. 150 mm. So, example tayo dito. So, determine the length of the splice joint of a 16 mm and 20 mm steel bars under the following conditions. A. Tensile reinforcement of a beam. B. Compressive reinforcement of a column. So, first, 16 mm muna tayo. Paano natin yung 16 mm steel bar if it is used for tensile reinforcement of a beam? So, kung pag gumamit daw tayo ng 16 mm na steel bar as main bars natin sa beam. So, ano yung formula natin kanina? 25 times the bar size plus 150. So, ito na nga yung ano natin. So, 16 mm yung ginamit, 25 times 16 plus 150 lang. So, ang sagot natin is 150 mm or 55 centimeters. So, yan yung splice natin pagdating sa tension. How about naman pag ginamit yung 16 mm steel bars for compressive reinforcement of a column? So, formula natin, 20 times bar size plus 150. So, ang magkakaiba lang dito ay ito, yung multiplier natin 25 tsaka 20. So, 20 times 16 plus 150 mm is equal to 470 mm or 47 centimeters. So, therefore, the splice joint for a 16 mm tension bar is 55 centimeters long and 47 centimeters for compression bars. So, ano ba yung natin? Yung tinatawag nating splice. Yung tinatawag nating splice ay yan yung, for example, yung connection natin na ito. For example, this is 10 meters. Sa beams to example, this is 10 meters. Pero yung bakal na ginamit mo is 6 meters lang. So, ibig sabihin, hindi aabot yung 6 meters natin. For example, ito, 6 meters ay hanggang dito lang. So, kailangan mo magdagdag ng additional na bakal dito para umabot yung yung bakal natin hanggang dulo sa 10 meters. So, ang tinatawag nating splice, ito. Yan. Ay, ito. Yan, ito. Yung length na ito yung tinatawag natin splice. Kasi ito yung connection na minimum lang to, connection natin para para safe yung connect natin sa dalawang bakal. Ngayon, for example, ito yung ito yung bakal natin. So, ito yung splice na tinatawag natin. So, bawal naman yung splice na ganito. For example, ito. Tapos, kukonektahin mo lang ng ganito. Sobrang liit naman yung splice connection natin. So, pag ganyan yan, may tendency na masisira agad itong natin. Kasi yung splice connection natin is not sufficient na connection. So, ito nga, di ba, sa taas. Nakalagay lang dito is minimum splice length. So, minimum, sabihin, hindi dapat bumaba dyan yung length ng splice natin. Pwede tumaas pero bawal bumaba sa minimum splice length natin. So, ba't tayo nalagay ng splice? Para mag-connect tayo sa kung hindi umabot yung bars na ginagamit natin. So, kung ganyan naman sa beam, how about naman sa column? Kung ito yung column, for example, first floor ito, plus first floor dito, tapos ito yung second floor. Paano yung bar mo ay hanggang dito lang? Example, ito yung natin. Ito yung second floor. Tapos ito yung first floor. Simula sa first floor hanggang second floor, yung 6 meters mo na bakal ay hanggang dito lang. Yan, parang hanggang ganyan lang. So, hindi umabot siya sa second floor. So, anong gagawin mo? Magdadagdag ka ng bakal. So, magdadagdag ka dito, magdadagdag ka dito, tsaka magdadagdag ka dito. So, ito yung tinatawag natin splice length. Ito yung connection between two steel bars. Yan, ito, tsaka ito. Magdadagdag ka kasi nga, nagkulang yung bakal natin. So, ito yung minimum connection nila. So, tulad nga sabi ko, pag masyadong maliit yung splice mo, maapektuhan yan ang strength ng steel bars mo. So, pag masyadong maliit nga, tayo maapektuhan. So, doon tayo sa safe tayo na na minimum splice length. So, pag minimum, so at least yun dapat yung ilalagay natin. So, for example, 16 mm to dito. So, dapat yung minimum na splice length mo is 47 centimeters. Yan. Yan yung minimum splice length natin. So, dito naman, splice length natin is 55 centimeters. So, sir, how about naman pag yung sa ground floor mo is 25 yung ginamit, tapos sa second floor is 16. Yan. Yan, ganyan yung natin. So, siyempre, yung yung natin dyan, ito yung connection na to. Yan. Since 16 yung ginamit natin sa taas, 16 yung nilagay natin bar size dito. Yes. Kung siyempre, mas malakas, mas maano yung load sa baba kaysa sa taas. So for 20 mm steel bars naman, input nyo yung 20 mm. Yan. So, kuha na natin yung splice length for tension bars and splice length for compression bars. So, ito yung mga mild steel minimum hook and bend allowance. So, minimum hook lang to. So, pwede pa lumagpas dito, pero bawal, no? Sumobra. Bawal kumulaw. So, length ng Ito yung mga kadalasan na hook natin. Ito, hook. Hook kasi ma-hook yung ano natin. Ano ba mukha ng hook? Tapos ito, bend. Bend yung ano natin. So, yan yung para sa mild steel. Tapos ito naman para sa high yield bars natin. Hook tsaka bend. Yan yung mga ano natin. Ma-discuss natin yan sila sa mga susunod na mga topics. Yan yung mga hook bend tsaka hooks and bend. So, to those who have not yet been exposed to detailed drafting work or actual field construction of reinforced concrete, will find it difficult to make a detailed estimate of various types of reinforcement required. So, the various type of metal reinforcement and estimator should be familiar with are ito. So, kung hindi pa tayo katulad sa inyo, hindi pa masyadong exposed sa detailed drafting, masyadong magiging mahihirapan kayo. Kaya, ngayon, dito pa lang, simulan natin na masanay kayo sa pag-estimate. Kasi pagdating nyo sa OJT nyo, baka bigla-biglain kayong ipa-estimate. Tapos, mamaya, hindi nyo pala alam kung paano mag-estimate ng bakal. Tapos, hindi rin kayo marunong mag-estimate ng concrete at masonry. So, at least dito, may matutunan kayo dito. So, punta tayo sa ano. So, meron daw tayong mga various types of metal reinforcement. So, meron tayong concrete hollow block reinforcement. So, ito. Meron tayong concrete hollow block reinforcement. Meron tayong footing reinforcements. Meron din tayong post and column reinforcements. Tapos, meron tayong reinforcement sa beam and girder. Yan. Meron din tayong reinforcement sa floor slab. So, tsaka meron tayong other types of reinforcement. So, isa-isa natin yung i-tackle. So, for concrete hollow block reinforcement, this is the simplest type of vertical and horizontal reinforcement placed in between layers and the hollow core of the blocks. This type of reinforcement is installed and spliced progressively with the rise of concrete block. So, first na ita-topic natin is concrete hollow block reinforcement. So, reinforcement of concrete hollow blocks. Steel bar as reinforcement is a requirement for all types of concrete and masonry work. So, yung last time, lang tayo ng di ba, ng concrete tsaka ng masonry works. So, hindi lang basta na paggagawa ka ng for example, kukompute ka ng floor slab na concrete lang yung i-compute mo. Siyempre, natin sa floor slab, meron din tayong kinocompute na reinforcement, bar reinforcement natin. So, sa masonry rin, so hindi rin pure hollow blocks lang yung pag-compute natin, tsaka ng concrete. Meron din tayong tinatawag na reinforcement. So, mag-base pa rin tayo sa National Building Code. Yun yung base natin. So, the National Building Code has a promulgated guidelines on how and what kind of reinforcement is appropriate for a certain type of work depending upon the purpose of which is to serve. So, the size and spacing requirements for concrete hollow block reinforcement must be indicated on the plan or specifications. So, the size and spacing requirements for concrete hollow block must be indicated on the plan or specifications sa mga natin. So, concrete hollow block reinforcement should be determined in 3 different ways. First is the direct counting method, the area method, and the unit block method. So, first natin is direct counting method. So, under the direct counting method, the vertical and horizontal reinforcement are counted individually in the plan. So, the length is also determined from the elevation. The hook, bend, and lapping splices are imaginably calculated and added to its length because it is very rare to see a plan in a large-scale drawing showing these particular requirements of reinforcing steel bars. Thus, estimators must be familiar with the hook, the bend and the splicing requirements to be able to work effectively if the plan is not accompanied with such detail. So, minsan sa mga plano natin sa hindi makikita yung mga requirements na with the hook, bend, and splicing. So, dapat sanay na yung mga nag-i-estimate sa atin. So, in the event that by estimating the direct counting method is somewhat difficult, one, we can use the area method with the aid of table 3-5. Yeah. So, mas madali yun. So, by estimating using area method is the simplest approach in computing the steel bar reinforcement for CHP. Yan yung natin. So, the values presented in the table included the allowances required for standard bend, hook, and tapping splice. So, mas preferred natin ang area method kaysa sa direct counting method. So, illustration 3-2. Ito yan, figure 3-6. So, from figure 3-6, determine the number of 10 by 20 by 40 CHP, the vertical reinforcement space at 80 centimeters, and the horizontal reinforcement at every 3 layers. So, ito yung figure natin. So, for vertical reinforcement, so ito yon, vertical reinforcement, yeah, space daw at 80 centimeters. Sa horizontal reinforcement naman natin, so every 3 layers daw merong bakal. Yan, so natin nyo. 1, 2, 3. So, tatlong layer ng bakal, tatlong layer ng hollow blocks may bakal. Tapos pagkatapos nyan, 1, 2, 3, may bakal ulit. So, first solution ang natin gagawin is solve for the area of the fence. So, ang length natin is 4 meters. Tapos, ang height is 2.6 plus 40 centimeters. So, ito, natural ground line. So, syempre, pagpunta sa baba hanggang footing, meron pa tayong hollow blocks na ilalagay doon. So, 40 centimeters. Huwag nyong mamamaya. Ilalagay nyo 2.6 lang. So, wala nang hollow blocks sa baba. So, hindi naman yun pwede. So, area natin is length times height. So, 4 meters by 3 meters. So, area natin is 12 square meters. Ayan. For vertical reinforcement space at 80 centimeters, refer to table 3-5. So, ito na yung natin. Table na gagamitin natin for area method. So, 12 square meters daw. So, itong column na to per block. Ito naman per square meters. So, per square meters yung gagawin natin. So, 12 square meters, anong multiplier ng 80 centimeters na spacing? So, 1.6. So, 12 square meters times 1.6 ay 19.2 meters long ang steel bars natin. Yan yung length ng steel bars natin. So, 19.2 meters long. Yan ay for vertical reinforcement only. Vertical reinforcement only. So, meron na tayong vertical. Hanapan naman natin yung horizontal. So, solve for the horizontal bars at every 3 layers. So, kanina ay centimeters, ngayon every layer. So, pag horizontal bar tayo, ang natin is by layer. Pag vertical naman is by centimeters. So, ito, per square meter tayo. Yan. So, 3 layers. So, 2.15. So, 12 square meters times 2.15 is 25.8 meters long. So, yan yung para sa horizontal reinforcement natin. So, 25.8 meters long daw yung kailangan natin. So, i-add lang natin yung vertical tsaka horizontal reinforcement natin na 19.2 tsaka 25.8. So, ang sagot natin is 45 meters. Ngayon, may 45 meters na need tayo na bakal. So, di ba nga kanina, yung sa available lang sa mga market natin na mga bakal na length is 6, 9, tapos may 10.5, tapos may 12, tapos may 13.5, etc. So, yung kadalasan na ginagamit natin is 6 meters. So, di-divide natin kung ilang pieces ng 6 meters na bakal ang bibilhin natin. So, 45 meters, ito, divided by 6 meters, 6 meters, 6 meters yung natin. Kasi ito yung kadalasan available sa market. Kasi baka magtaka kayo saan nang kuha yung 6 meters. So, kung gusto nyo 9 meters yung gamitin nyo, okay yan. So, depende yan sa inyo. So, 45 divided by 6 is 7.5. Since wala naman tayo nabibiling kalahating length lang ng 6 meters na bakal, i-round off natin. So, say, bibili tayo ng 8 pieces na 10 mm by 6 meters long na bakal. So, how about naman pag pag 9 meters yung bibilhin natin. So, 45 divided by 9 is equal to 5. So 5 pieces. So, 5 pieces na 10 mm by 9 meters long. So, depende yan sa inyo kung saan kayo mas preferred yung pag-estimate natin ninyo. So, ito, pag 9 meters long. Ito naman pag 6 meters long. So, kanina, yon by area method. Ito naman by unit block method. So, first, find the area. So, area natin is 4 times 3. So, 12 square meters. So, CHB. Hindi pa pala natin naka-compute yung CHB kanina. So, kung 12 square meters to, so in every 1 square meter nga natin is 12.5 pieces of CHB. So, 12 square meters times 12.5 is 150 pieces of CHB. So, vertical reinforcement at 80 centimeters spacing length of steel bar per block. So, per block to. So, punta tayo ulit doon sa 3-5 na table. Ito, kanina, is per square meters. Ito naman, per block. So, titingnan lang natin kung anong multiplier pag 80 centimeters. So, 80 yan, per block tayo. Tingin tayo sa per block is 0.128. So, yan yung multiplier natin para sa vertical. How about naman sa horizontal? So, per block ulit, tingnan tayo sa per block kasi per block yung pinag-uusapan natin, hindi per square meter. So, spacing natin is 3 layers. So, ito yung multiplier natin, 0.172. So, direct yung natin, titingnan lang ulit natin sa table. As long as may table tayo. So, ito yung per block method, per unit block method. So, 150. So, hindi natin magagamit to kung wala tayong number of CHB. So, 150 times 0.128. Ito yung multiplier natin pag 80 centimeters. So, 19.2. So, magkaparehas lang kanina. So, pag horizontal bars naman is 150 pa rin. Hindi magbabago yung number of blocks. So, times, multiplier natin is 0.172. So, meters is 25.8 meters long. So, same lang sila. So, depende yan sa inyo kung ano yung mas preferred nyo, if it's either by area method or by unit block method. So, kung wala hindi naka-state sa problem, depende yan sa inyo kung ano ang mas preferred nyo. So, tulad ng kanina, sagot natin is 45 meters long. And ang ano natin is 7.5. So, mag-order tayo ng 8 pieces, 10 mm, 6 meters long na bakal. So, alam na natin yung para sa sa hollow blocks o sa walls natin so compute naman natin yung para sa tie wire. So, syempre, hindi naman natin maano yung mga bakal. For example, ito yung mga bakal natin. Yan. So, hindi naman yan magkukonek ng sarili nila. So, maglalagay tayo ng tying wire. Dito, kukonek natin yan, tying wire. So, alam ko naman na alam nyo na maglalagay talaga tayo ng tying wire. So, hindi naman natin ipapatong lang yung mga bakal natin. So, paano ba tayo mag-solve ng tying wire? So, tie wires refer to gauge number 16, galvanized iron wire, popularly known as GI tie wire. So, tie wire is used to secure steel bars into the designed position. So, ordering tie wire is not by feet nor by meter length but in kilograms or roll. So, pag bumili tayo ng tying wire per kilogram or roll. So, one roll is equivalent to 45 kilogram. So, ang bigat pala nun. Or approximately 2,385 meters at 53 meters per kilogram. Yeah. So, one roll is equivalent to 45 kilograms or approximately 2,385 meters at 53 kilograms per 53 meters per kilogram. So in every meter, 53 meters is 1 kilogram. So the length, tandaan niya na baka madaya kayo na ang length ng one roll is equivalent to 45 kilograms. Pag bibili kayo ng isang roll ng tying wire. So, the length of each tie wire depends upon the size of the bar to be used. Tie wire is cut into length ranging from 20 to 40 centimeters for small and medium-sized steel bars. For larger steel bars, the length of ties varies depending upon the convenience of the steelman. So, depende yon sa steelman natin kung gaano kahaba yung puputulin niya yung pag masyadong malaki yung steel bars natin. So, this particular item of construction material is always included in the bill of materials, but never been computed. The quantity is determined through a more or less calculation. In short, it is a quantity with uncertainty of its accuracy. The only thing that is certain is either it is overestimated or underestimated, which is bad as the other. So, kadalasan, hindi na ito yung nakakaligtaan sa pag-estimate. Minsan, overestimated tong tie wire natin. Minsan naman, underestimated. So, which is bad. Yan yung natin. So, length of tie wire reinforcement. The common size of steel bar reinforcement specified for hollow block work is either 10 mm, 12 mm, or 16 mm, depending upon the plans and specification. So, kadalasan daw na common size ng steel bars na ginagamit natin para sa concrete hollow block is 10, 12, and 16 mm. So, pero kadalasan talaga yung ginagamit natin is 10 or 12 lang talaga. For this particular size of reinforcement, a 20 to 40 centimeters long tie wire folded at the center is satisfactory. So, kung ito lang naman yung mga bakal na gagamitin natin, ang length lang ng tie wire na putulin natin is 25 to 40 centimeters lang naman. So, kung yan lang na yung kadalasan na gagamitin natin. So, try natin, tingnan natin. Yan na. Huwag yung makalimutan ito yung kadalasan na length lang ng tie wire natin pag ito yung mga bakal na gagamitin natin. So, 25 to 40 centimeters. So, table 3-6, the number 16 GI wire for CHB reinforcement per square meters. For vertical spacing, ito yon, centimeters yan, naka-centimeters. Horizontal spacing, so, kilogram per square meter. So, 40 at 25 centimeter tie, 30 centimeter tie, 40 centimeter tie. So, continuing the solution of illustration 3-2, find the required tie wire in kilograms if the reinforcement are spaced at. So, ito yun. Meron tayong vertical bar spaced at 3 centimeters and 1 horizontal bars at every 3 layers. Ito yung condition natin. Tapos, meron pa tayong condition isa. Vertical bars at 60 centimeters and 1 horizontal bar at every 2 layers. So, tie wire in kilograms. So etong number 1, yan yung given natin kanina. Ayan yung ano natin. So 80. So area is 4 times 3. Yan yung ano natin, illustration 3-3, yan yung kanina. So ito yung area natin. First is solve for the area, 12 square meters. So refer to table 3-6. Along 80 centimeters and spacing 3 layers. So horizontal reinforcement at 30 centimeters long tie wire. So 80 tapos 3 layers daw. So 'di ba sabi ko kanina, ang kadalasan na length ng ano natin, tie wire is 25 to 40. So ito 'yon, 25 to 40. So 25, 30 or 40 yung kadalasan na range ng ano natin dito sa table. Sa table lang natin. So dito, ang ginamit niya is 30 centimeters long. So pagitan ng 25 at 40. So hanapin lang natin sa table. Vertical spacing is 80. So 80, pili natin sa tatlo. Pero kasi nga horizontal natin is 3 layers. So ito yon. Ito yung ano natin yan. Ito yan. So since ang gagamitin natin is 30 centimeters tie, yan yung haba ng tie natin. Yan, 30 centimeters yung gagamitin natin. So hanapin lang natin dito. So ito. 0.024 ang multiplier natin. So 12 square meters times 0.024 is equal to 0.29 kilogram number 16 GI wire. So wala pang kalahating kilo. So solution 2, ito yan. Vertical bars at 60 centimeters naman, tapos 2 layers lang. So ganyan pa rin yung area, 12 square meters. So yan. So tingin tayo ulit sa 60 centimeters. Ito yan, ito yung tatlo. Since 2 layers lang yung horizontal, ito yan. Yan. So ito, yung yung length ng tie wire is nakadepende sa inyo. So depende yan sa inyo. Ito lang range naman yan, 25 to 40. So ito yung table natin. So since 20, 30, 40 lang yung pagpipilian, dito lang tayo magpipili sa tatlo. So 30 yung pipiliin natin. So ito yung multiplier natin, 0.044. So 12 square meters times 0.044 is 0.53 kilograms of number 16 GI wire. So wala, kalahating kilong tying wire lang yung gagamitin natin para doon sa natin, sa wall natin. So more tie wire will be presented succeeding examples of steel. So for example, kung gusto niyo i-estimate yung bahay niyo, estimate niyo yung wall niyo, tapos hindi niyo alam kung gaano maraming kilo ng tying wire yung bibilhin nyo, magtingin lang tayo sa table. Hanapin nyo muna yung area ng wall ng bahay nyo. Tapos, sabihin nyo na yung vertical spacing ay 80. tapos 3. Tapos kung gusto niyo gumamit ng 40 centimeters sa tower, so ito yung ano natin, times lang natin. Makukuha niyo na yung kung ilang kilong GR wire yung gagamitin natin. So, next is, punta naman tayo sa independent footing reinforcement. So, independent column footing is also referred to as an individual or isolated thing. The ACI code, or the American Concrete Institute code, provides that the minimum and underground protective covering of concrete to steel reinforced shall not be less than 7.5 centimeters or 75 mm. So, di dapat daw bumaba sa 75 mm yung concrete cover natin. So, the reinforcement for this type of structure is determined by direct counting from the detailed plan under the following procedures. So, determined by direct counting. So, ito yung example natin sa individual reinforcement. So, bawal daw, ito yung tinatawag nating concrete cover. So, cover, tatakpan natin yung mga bakal natin para hindi ma-expose sa mga elements. Kasi pag na-expose yan sa tubig, kakalawangin yan. So, 75 mm to, 75 mm rin to, 75 mm rin to. Ito yung minimum. So, pag bumaba pa dyan, sabihin, bawal na yan. So, know the actual dimensions of footing as to its length and width. So, consider 7.5. Yan yung mga conditions natin. So, one important consideration in estimating steel bar reinforcement is to find the required length and quantity of a particular reinforcement, then choose a commercial length bars which, when cut into required size, will minimize unwanted cuts. So, minimize. So, ito yung mga sobrang sobrang pasobra sa mga cuts natin. So, for instance, if 5 pieces of 1.2 meters long is needed, so 5 pieces lang ng 1.2 meters long is needed, the most ideal order is 6 meters long steel bar. Likewise, if the work requires 2.5 meters cut length, the order will not be 6 meters, but 7.5. So, for example, ito, 5 times 1.2 is equal to 6 meters. So, wala tayong pasobrang cut. So, we minimize the unwanted cuts. So, pag 2.5 naman yung cut length natin, so, kung kailangan natin ay 5, so, 2.5 times 5, yeah, magkano? So, 5, 2, 12.5. So, gagamit tayo ng 7.5 meters long. Kasi, ang kailangan, kung puputulin natin yan, 7.5. So, meron tayong 2.5, 2.5. So, meron tayong dalawang 7.5 meters lang gagamitin natin. So, may pasobra tayong So, sakto yung natin, yung 7.5 meters na steel bar. Kung ganun yung gagamitin natin. So, subok tayo. So, illustration 3-4. From figure 3-8, ito yan. Find the number of 12 mm steel bars required if there are 24 footings. Oh, daming footings. 24 daw, having a general dimension of 1.5 by 1.5. So, hanapin daw ng number of 12 mm steel bars required for 24 footings. So, find the net length. First is find the net length of one cut reinforcing bars. So, ito yung dimension ng natin. So, square. 1.5, 1.5. So, net length, sabihin, binawasan natin yung ano natin, yung total length. So since ito yung mangyayari, kung 1.5 ito, diba sabi nga, ang minimum na concrete cover is 75 mm. So 75 mm rin dito. Tapos 75 on all sides. So kung 1.5 itong total na to, tapos pabawasan natin ng 75 in one side and the other side. So ang magiging formula natin is 1.5 minus 2 times 0.075 meters. So, yung net length ng bakal natin na gagamitin is 1.35. So, safe na to kasi yung length ng natin, concrete cover is 75. So, itong 0.075 dito, ito yung concrete cover natin. So, ito yun. Ito, tsaka ito. Kung dito ka naman titingin, ito yon, tsaka ito rin yun. Yeah. So, find the total number of this. So, base, tingnan natin dito. Ito yung sana eh. Tingnan natin yung drawing sa plano. Ito yung sa ano. So, bilangin natin yung number of bars sa plano. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, gumamit siya ng 10 pieces of 12 mm. So, that is on the one side. So, on the other side, since square to, so kung 10 dito, so 10 rin sa kabilang side. So, 20 pieces. So, ito yung mangyayari. 10 times 2 kasi nga square is equal to 20 pieces. So, of 12 mm at 1.35 meters long. So, kapag square, pag rectangular naman ito, example, pag ganito, direct counting, kaya sinabi natin by direct counting yung mangyayari natin. So, kung isang side is, sabihin natin dito sa side na to is 10, dito is 5. So, 15 totals lang yung natin, yung bars. So, since by direct counting, natin na 20 pieces yung bakal natin. So, ang total, ito ay 20 pieces for one footing. So, ang total cut bars natin is 24 times 20. Saan ang galing yung 24? Yung 24 is the number of footings based sa tanong. So, 24 footings daw. So, 24 times 20 is 480 pieces of 12 mm at 1.35 long na bakal. So, yun na yan. So, kailangan natin ng 480 pieces ng 12 mm at 1.35 meters long. So, meron na tayong, alam natin yung pieces, para yan. Pero hindi natin alam yung commercial length na gagamitin natin. So, if 6 meters long steel bar will be used, we obtain the following cuts. Kapag gagamit daw tayo ng 6 meters na bar, ang 6 meters divided by 1.35 is equal to 4.44 pieces. Yeah. So, kung gumamit tayo ng 6 meters long na bakal, lalabas is 4.44 pieces. So, the result simply means that in 6 meters long steel, we could get 4.44 pieces of 1.35 meters long. So 6 meters, ilang piraso ng 1.35 meters long ang makukuha natin? 4.44 pieces. Since may fraction to 4.44, hindi natin because 0.44 is less than 1.35, hindi natin ko-consider to. So, ang ko-consider lang natin is yung whole number. So, consider lang natin is yung 4. So, since nga may sobra baga, ito yan, parang ganito. So, 1.35. Tapos, another 1.35. tapos another 1.35, bali tatlo na yon. Tapos another 1.35, bali 4. Tapos yung sobra doon is 0.44. So since ito ay masyadong maliit na, i-disregard din natin. So 4 lang yung natin. So 1, 2, 3, 4. So after that, i-divide natin yung 4 sa total pieces. So 480, ito yung 480 pieces ng 1.35 meters long divided by 4 pieces, hindi na 4.44, 4 pieces. So ang kailangan natin is 120 pieces of steel bars at 6 meters long. So pagbibili na tayo, ang kailangan natin is 120 pieces of 10 mm. So ang kailangan natin is 120 pieces of 10 mm diameter bar by 6 meters long. So, naulit ko, hindi na natin consider yung 0.44 nga kasi nga less than na siya sa length ng 1.35. So, whole number na. For example, 4.5 ang lumabas. Hindi natin consider yung 0.5, yung 4 lang. Yung whole number lang. So, since may nakuha tayong 480 pieces kanina, i-divide lang natin sa 4. So, makukuha natin is 120 pieces of steel bars at 6 meters long. So, yan yung bibilhin natin sa market. So, may comment dito. Take note that 0.44 of 1.35 is equal to 0.59 meters only. It is shorter than the required 1.35 meters cut. That is the reason why the fractional amount of 0.44 was set aside using only the whole number 4 as divisor of 480. So, excess cuts, however, may be reserved for other needs in the construction. So, kaya nga, hindi natin consider yung 0.44 kasi nga, yung 0.44 ng 1.35 is 0.59 lang, which is lesser than 1.35. So, kung sa mga excess cut naman natin, pwede naman natin gamitin yun sa ibang needs natin sa construction. So, example of common errors in estimating steel bars. So, using the problem in 3-4, figure 3-8 yung kanina, the length of one cut reinforcing bar is 1.35. Thus, so the total of cut bars in one footing, so kanina nga, binilang nga natin na 10 pieces sa isang side. So, since it is square, times 2 lang natin. So, 20 pieces per footing. So, total cut bars is, so there are 24 footings. So, 20 pieces for one footing. So, times 24 lang natin para makuha natin yung total para sa isang, sa 24 footings. So, 480 pieces. So, since total length of this cut bar is 480 times 1.35. So, ito yung 648. So, tinimes niya yung 480 pieces times 1.35. So, convert natin into 6 meters long. So, yan. Ito yung common error natin sa pag-compute. Kadalasan, for 880 times 1.35. So, nakakuha siya ng 648. Tapos, dinivide niya by 6 meters kasi 6 meters yung gagamitin niya. So, ang lumabas is 108 pieces. So, comparing the results of the two procedures, the former has 120 steel bars while the latter has only 108 or a difference of 12 pieces. The difference is the result by including the fractional amount 0.44 as part of the divisor in the second solution. Yan. Yan yung result ng pag sinasama natin yung fractional amount. Ito. Example, parang ang nangyari doon is yung 0.59 niya. Ganito yung ginawa niya. 0. Parang kinumbine niya yung 0.59 meters. Parang kinumbine niya. Kaya, ang nangyari, naging 108 pieces lang ng 6 meters yung which is wrong. Kaya dapat hindi ganyan yung pag-estimate natin. Yung pag-estimate natin, hindi natin sinasama yung excess cut. Kasi magmamali yung estimate natin. So, tingnan nyo, there is a difference of 12 pieces. Madami yan. Madaming natin yung nasayang kung hindi natin aayusin yung pag-estimate natin. So, this is a common errors in estimating steel bars. So, hindi dapat ganyan yung pag-compute natin. So, ito yung pag-compute natin. So, 480 divided by the whole number na natin, na-compute. Yan. So, the second solution, however, could be correct if the quotient in dividing the length of one commercial steel bar by the length of yields a whole number. Yan. Yields a whole number. So, the second solution could be correct if the quotient in dividing the length of one commercial steel bar by the length of one cut. Ito yan sa taas. Yung sa taas. If, yan, whole number. Pero, kasi nga, ito, for example, 6 divided by 1.35. Pag yan ay whole number, yung second solution, pwedeng tumama. Ito yan. Since 4.44 yung lumabas, hindi natin magagamit ito. Pag whole number lang. So, on the contrary, if the result has a fractional amount, the second example will not give a correct answer. So, illustration 3-5 would be correct under the following illustration. Ito. Tingnan natin ito. Ulit ko kapag yung quotient ng in dividing the length of one commercial steel bar, ito yun, yung 6 meters, 9 meters, etc. divided by one cut yields a whole number, tatama ito. Tatama yung itong solution natin. Tatama ito. So, since hindi, may fractional amount, magmamali yung second solution natin. So, try natin itong sa isang illustration kung tama yung sagot natin. So, illustration 3-6. From figure 3-9, determine the number of 12 mm diameter steel bars, including the tire wire in kilograms. There are 30 pieces of 1.15 meters by 1.15 meters independent square footing. So, meron daw tayong 30 pieces na sinabi na dito, 30 pieces na 1.15 na 1.15 square footing. So, meron tayong 1.15. So, hanapin natin yung net length. Okay. Determine the length. So, sa problem na to, merong hook yung bars natin. So, net length is 1 meters. Na nakuha yung 1 meters. Yung 1 meter. Ito yan. 1.15 minus 2 times 0.075. Yan yung natin. Kung saan nakuha yung 1 meter. So, lalabas 1 meter. So, net length is equal to 1 meter. Ito lang yung 1 meter natin. Yan. Ito lang yan. So, meron siyang hook na 0.2. Yan. 0.2. So, in one side is 0.1. In another side is 0.1. So, 0.1 plus 0.1, 0.2. So, net length natin is 1.2 kapag may hook. So, find the total number of cut bars in one footing. So, in one footing, bilangin natin. So, 1, 2, 3, 4, 5, 6. So, this is a square footing. So, times 2. So, 6 times 2. So, there are 12 pieces of steel bars in footing, one footing. So, since there are 30 pieces of 1.15 meters na square footing, so there are 30 30 pieces or 30 na footings. So, 12 cut bars times 30 footings. So, lalabas is 360 pieces. So, find the total length of 360. So, ito yung ano natin. Ito yung para sa solution 2. So, 360 times 1.2 is equal to 432 meters. So, try natin 6 meters divided by 1.2 is equal to 5. Is equal to 5. So, whole number yung commercial length divided by the cut length. Yan. So, pwede natin gamitin yung solution number 2 natin. So, direct na tayo dun sa 360 times 1.2. So, ang length ng ano natin is 432 meters. So, i-divide natin. So, meron tayong 432 meters ng cut length bars. So, divided by 6. So, meron tayong 72 pieces ng 12 mm by 6 meters steel bars. So, there are comments. The above solution is correct because in dividing 6 meters by 1.2, it exact of 5 meter of 5. So, diba sabi ko kanina, yung sabi dun sa ano kanina na pag whole number daw, whole number, yung makukuha natin pag dinivide natin yung commercial length divided by cut length, makukuha yung solution number 2 natin is tama. So dividing 432 by 6 meters yield an exact number of 72 pieces at 6 meters steel. Therefore, all cuts are exactly the same without excesses. Yan yun natin. So, solve naman natin yung same problem using the first method. So, kanina nga, ulit. Tapos, ito yung kanina. The net length of one cut bar is 1.2. Total number of bars for 30 footings is 316 pieces. So, ito lang yung kanina 10, 6 divided by 1.2. So, 5 pieces. So, yung natin, simply means that 6 meters long steel bar will be obtained 5 pieces at 1.2 meters. Divide the total cut bars for 30 footings by 5. So, meron tayong 360. Ito yun, divided by 5 is 72 pieces. So, pag whole number talaga, yung makukuha natin, okay yung solution 1, solution 2, pag whole number. Pero pag may decimal, pag naka-decimal, yung solution 1 is okay, pero yung solution 2 is not. So, mayroon na kami dito. So, the question now is, when to use the first method and when to use the second method. The following rules will help in making the right choice. So, first is, determine the net length of one reinforcing bar. Tapos, divide the 6 meters or in chosen commercial length of steel bar. So, for example, napili mo, first ay kukunin nyo daw muna yung net length ng cut bar. Tapos, divide 6 meters or any chosen commercial length. So, ang mapili nyo is 9 meters or 7.5. I-divide nyo siya by the net length of the cut bar. So, if the resulting result of one steel bar divided by the cut bar is a whole number, use the second method. Pero pag hindi naman, pag fractional naman yung value, use the first method. So, yun yung condition natin. So, next problem sa next video natin is estimating the footing tie wire.